Three identical cones each have a radius of 50 and a height of 120. The cones are placed so that their circular bases are touching each other. A sphere is placed so that it rests in the space created by the three cones as shown. If the top of the sphere is level with the tops of the cones, then the radius of the sphere is closest to. This diagram illustrates the cones if you're looking at this from the perspective of just their bases, the circular part of the cone. And you'll notice, of course, that they touch each other. And what I'm going to draw is the centers of these circles, and then I'm going to connect them like that. And these circles are all identical, and therefore the distance from the centers are also identical, because this is the radius, and so on, right? So this is an equilateral triangle, and that represents the center of this diagram. Now, one thing that's important to understand is that when you place this sphere in that position, the center of the sphere will line up exactly with the center of this equilateral triangle. And what is the center of an equilateral triangle? Well, it is known as a centroid. And now I'm going to draw the diagram to illustrate what is the centroid, and we then have to figure out the distance from the vertex to that centroid. So here is our equilateral triangle, and the first thing I'm going to do is draw lines from the vertex to the opposite sides, like that. And the centroid is this point right here, that one that I just drew the red dot. And we have to figure out the length of this segment from the vertex to the centroid. So how do we do that? Well, one thing we know that this is most likely a 30, 60, 90 triangle. This is, of course, a right angle. This whole angle was 60 because it's an equilateral triangle. So if I cut it in half, this angle is 30. And therefore, since this angle must be 90 minus 30, it's 60. So it is indeed a 30, 60, 90 triangle. And if I draw that triangle over here, I will be able to illustrate what the distance is from here to here. Well, we know that from here to here is the radius of the cone, and they told us in the question stem that that is equal to 50. So this is 50 in terms of a numerical value. But because we know that in a 30, 60, 90 triangle, the ratio of the sides are 1, 2, and root 3, we can now figure out this side. That side, if I call it x and use the ratios, x over 50 is equal to 2 over root 3. So therefore x is equal to 100 over root 3. So that represents the distance from the vertex of the triangle to the centroid, and that is going to help us later in the question. So now I have to bring in the sphere. So far we've just been discussing the three cones, but remember there's a sphere that has been placed, and now we have to try to figure out the radius of that sphere. So this diagram shows you how that sphere has been placed. Now I have to draw it in 2D and try to figure out the radius of that sphere. So here is my 2D representation. This is the cone, this is the sphere. I'll call this point A. I'll call this point B right here. And then we'll call this, of course, the radius, big R. This is also a radius of the sphere, big R. And this point that is tangent, I'll just call that C. And then top to bottom, this green line represents the height, which is the same as the height of the cone. And if you remember, that height is equal to 120. They give you that in the question stem. All right, now this from there to there represents the radius of the cone. And if you remember, that was 50. Now we come to the point of the question where this value comes in. Remember, 100 over root 3 was the distance from the vertex to the centroid, right here. The distance from the vertex to the centroid. And if you remember, the sphere will align with the centroid. The center of that sphere will align perfectly with the centroid. And therefore, since this is the sphere, this is the centroid right there. And this is the center of this sphere. Those two will be aligned. They'll be right in the same line top to bottom. And this, of course, represents this point, the center of the cone, the circle part of the cone. So therefore, from here to here is essentially the distance from the vertex of that triangle to the centroid. Let me show you in this diagram. This is the center of that cone. This is also the vertex of that triangle. And if you draw a line from the vertex right here to the centroid, right here, that represents this distance from here to here. And I think that is probably the most challenging part about this question. So that distance is 100 over root 3. Okay? Now 100 over root 3 is approximately 57.73. So therefore, this distance from here to here has got to be 57.73 minus 50. So this is approximately 7.73. The distance from there to there. Okay? Now, one important point that needs to be mentioned in this question before I move forward is that you've got two tangents. One is from A to C, right there. That C point is tangent to the circle. And the other one is from A to B. That point B is tangent to the circle. And because AB and AC are both tangent to the sphere, it's really the sphere that we are talking about, AB will be equal to AC. And that is something that we will need to use a little bit later in the question. So now we have to figure out R. So what I would like to do is draw a line from the center of the sphere down to this point right here. And the reason is that's going to help me figure out R. And I will label that distance Y. Okay? And then this is, of course, a tangent point, C, so that means that is a right angle. And this is a perpendicular that we had drawn earlier, so that is a right angle. So now, this will be two Pythagorean relationships. So the first one involves this triangle right here. And that will give me the following equation. Y squared is equal to 7.73 squared plus this distance. Well, that distance is the full top to bottom, which is h, minus this radius, minus r, like that, all squared. And that gives me y squared is equal to 59.83 plus h is 120, so it's 120 minus r, all squared. So that's the first equation. The next equation will come from this right triangle right here. And that one will give me y squared is equal to r squared plus this distance right here. And I can call this point D, and therefore we can just call that CD. But what's CD? It will help if I knew the numerical value for CD. That way I can just set these two equations equal to each other and solve for R, and we'll be done. So how do we figure out CD? That's the second last step to this question. Well, let's figure that out. First, we will need to figure out the distance from A to D, that whole distance. And that can be done using Pythagoras, once again, using this triangle. Using that triangle, we have h squared plus this small r squared is equal to AD squared. H, of course, was 120. Small r was 50. And then we have AD squared. Solving, we get AD is equal to 130. All right, so we've got part of that. Now we also know that AC is equal to AB. We figured that out earlier right here. So AD minus AC would give me the numerical value for CD, like that. AD we just figured out was 130. AC is the same as AB, and AB we know is from here to here, which is the same as here to here, which is 100 over root 3. So 130 minus AB, which is equal to 100 over root 3, which is 57.73, is equal to CD. So therefore, the numerical value for CD is approximately 72.26. And there we go. We can put that back into this equation, and we'll get y squared equals large r squared, which is the radius of the sphere, plus 72.26 squared. And now we can set this equal to that and solve for r. So 59.83 plus 120 minus r all squared is equal to r squared plus 72.26 all squared. And this will help us solve for the radius of the sphere. So here we go. This becomes 59.83 plus 14400 minus 240r plus r squared is equal to r squared plus 5222.2. The r squareds cancel, and I'm going to put the 240r on this side, and all of these numbers, when combined, give you a value of 9237.63 approximately. And solving for r, you will get a value of 38.49. And this is the numerical value of the radius of the sphere, 38.49. Let's go back and see what are the answer choices. 38.49 is closest to answer D for number 25.